is Neelam, and this is my video demonstration for the Coursework 2 of Advanced Server Side. I'll begin with the application demonstration. The platform requires strictly controls and access starting at registration, requiring users to sign up with a valid university email domain. The system also enforces strong password complexity. Once registered, a secure token is generated to verify the mail, which we get in the VS Code, in the VS Code terminal. Here we are logged in as an alumni, where we can upload our profile picture. Then the user is routed to their profile dashboard. Here they can manage their professional data set, adding degrees, certifications, and employment history. Moving to the bidding marketplace, alumni can place blind bids for featured slots. The system ensures the business rules perfectly. Bids can only be increased. Users can capped at 3 wins per month unless they attend a university event. And the interface provides winning or not winning status without revealing the highest bid amount. Now I'm going to log in as an admin using the admin's email. If we log in as an admin, we access the University Analytics dashboard. The interface transforms the raw alumni data into actionable intelligence, like as required. The data dashboard features interactive charts visualizing critical skills gap, then emerging tech trends and top employers. The data is fetched dynamically via the API and can be filtered by academic program or expand to CVS. The admin can also create events and mark attendance for an alumni and see the past events or the upcoming events. For the view alumni list, it gives all the existing alumni, the list of all existing alumni, where you can search and filter alumni by the name, program, and add an industry name, look for those alumni, and add a graduation year and look for them. And when you clear the filters, it again gives the existing list of all the alumni. And admin also have the access to reviewing who is the alumni of the day and go to their profiles. Now I'm going to log in using the developer's account. Finally, the developer portal acts as an API gateway. The The technical users can generate highly scoped API keys, such as keys restricted solely to recording the alumni of the day endpoint. The raw key is shown only once, and developers can monitor the API usage logs and revoke keys directly from the interface. You can also reset the password and go to the API documentation for the Swagger. Moving to the code base, I architect this application as a modular monolith to ensure clear separation of concerns. I group the backend logic by features rather than by file type. The routes layer defines the endpoints and attaches validation and authentication middleware. The controller layer handles incoming HTTP requests and passes data back to the client. The the service layer encapsulates all core business logic, such as the blind bidding rules or data aggregations. Let me explain how the data flows from the database to the analytics shop. For data management, I have used SQL. The database is heavily normalized into third normal form. Instead of putting massive amounts of raw data, Drizzle executes SQL aggregations directly onto the database. For example, the skill gap endpoints queries the certification table groups by certification name and counts the occurrences. If the admin filters by academic program on the database, the service dynamically adds an inner join to the degrees table to isolate that specific cohort. The controller sends the aggregated JSON data to the front end, which feeds directly into the chart.js library. To meet the rubrics color-coded insights requirement, I implemented logic on the front end to dynamically assign colors. Red for critical gaps over 70, then amber and orange for emerging gaps. When an admin changes the program filter dropdown, the existing chart.js instantly are destroyed. New filter data is fetched from the API, and the charts are dynamically rebuilt to ensure a smooth interactive experience. I implemented Helm.js to ensure secure HTTP headers and a strict content security policy. Course is tightly restricted by environment variables to allow only requests from trusted origins. A rate limiter is applied globally through throttlered traffic to 100 requests per 15 minutes, mitigating brute force and DDoS attacks. CSRF is inherently mitigated because the application relies on bearer token passed explicitly in the authorized header rather than relying on automated um, cookies. Furthermore, I added strict origin verification for state changing endpoints. Finally, I have implemented JSONB scopes for API keys by custom require API key middleware intercepts requests, hashes the incoming keys, and explicit verifies that the client has the exact permission scope required to access their endpoints, enforcing the principles of least privilege. For user authentication, I built robust access and refresh token architecture. The access token is a short-lived JWT for 15 minutes that minimizes the window of exposure if intercepted, while the refresh token handles secure background re-authentication, password, it's um, then are computationally hashed using bcrypt. For external clients using API keys, I ensure that raw keys are never stored in the database. When a developer generates a key, the backend hashes it using SHA 256 combined with a secure environment before saving it to the database. This ensures API keys cannot be reserved, engineered, or stolen even if the event of the database breaches. By combining a modular architecture with optimized database queries, strict cryptographic security, and granular scoping, the application is both highly scalable and highly secure. Thank you for watching my presentation.